In this video, we learn how to find how many terms there are in a finite arithmetic sequence. And for that, we're going to be working through the example you see here, in which we're simply told, find how many terms are in this arithmetic sequence. And as we can see here, we're given the first few terms as well as the last term of the sequence. The first three terms being 5, 8.5, and 12, and the last term in the sequence is 89. Okay, well, as I always do, let me start by writing SOL here for solution, and now we can get started. Since we're told that we're dealing with an arithmetic sequence, and since we're dealing with the terms of that arithmetic sequence, it's worth reminding ourselves of the formula for the nth term. That is, the nth term of an arithmetic sequence is equal to its first term, u sub 1, or simply u1, plus, in parentheses, n minus 1, times the common difference d. And I'll go ahead and box that formula. That's the formula for the nth term of an arithmetic sequence. Now, to find how many terms are in this sequence, all we have to do is find which value of n inside the formula we have here leads to the term being equal to 89. So let's see how that works. I'll start off by copying this formula. That is, un, the nth term, is equal to u1 plus n minus 1 times d. Now, to use this formula, we need the first term, which we have right here. It's equal to 5, so we can already state that u1 equals to 5. And we need the common difference, d. Remember, the common difference is the amount we add to get from one term to the next of the sequence. And if you can't see what the common difference is right away, remember that you can always find its value by taking any term of the sequence and subtracting the previous term. In other words, we could say that d is equal to 12 minus 8.5. Or we could also say that d is equal to 8.5 minus 5. And in fact, I'll write that here. The common difference d is equal to 8.5 minus 5. And you can of course check, but 8.5 minus 5 is equal to 3.5. Done. We now have the common difference d. Okay, now that we've made a note of the first term as well as the common difference, we can now write the formula for the nth term of this arithmetic sequence. And we can go ahead and state that the nth term is equal to 5, that's the first term, plus n minus 1 times 3.5. And now that that's done, we can figure out which term, or which value of n, leads to the term being equal to 89. All we have to do is replace the left-hand side of this formula by 89, and then we'll solve for n. And so let's see, that would turn into 89 equals to 5 plus, in parentheses, n minus 1, times 3.5. Now, solving this equation, the first thing I'll do is get rid of the 5 on the right-hand side, and I do so by subtracting 5 from both sides of this equation, so that it becomes 84 equals to n minus 1 times 3.5. And now I'll get rid of this 3.5, which is multiplying the right-hand side, and I do so by dividing both sides by 3.5. And now for the left-hand side, if you're uncomfortable dividing 84 by 3.5, with our calculator we can quickly calculate 84 divided by 3.5, and that's equal to 24. And so we have 24 equals to n minus 1. But now that we've gotten rid of that 3.5, this pair of parentheses serves absolutely no purpose whatsoever. So we can get rid of them, and we can state that 24 is equal to n minus 1. And finally, adding 1 to both sides of this equation leads to 25 equals to n. Or rather, n equals to 25. And we're done. We now know that this formula will equal to 89 when n equals to 25. In other words, we now know that the 25th term of the sequence is equal to 89, which in turn allows us to state that there are 25 terms in the sequence. And we're done. That's the final answer. And that's it for this tutorial.